Now, our next task is to complete the experiment number 4. Here we have to select the relevant feature using the suitable techniques. Now, already we have seen that totally there was 15 features, but when we use the analysis here, we will get out of 15 features only this much features are used for the analysis. Now see, these are the names of the features: standard error, skewness, kurtosis, mean, median, mode, minimum, maximum. How these features are selected, that will be the question. And see here, this graph shows the effect of number of features on the accuracy. Suppose there are 15 features or 13 features. See here, with the 13 features, the accuracy will be 96.3. And if we have to see minimum how much features we have to require to get the same frequency. Here you can see that from 13 to 12, again the same accuracy for 11, same accuracy 96.3 and all. This is continued up to the sixth number of features. Sixth number of features: kurtosis, standard deviation, skewness, variance, maximum, minimum. And after 6, the accuracy is not going to change, and before 6, the accuracy is going to increase. Hence, like the 6 years are sufficient to consider to reduce the computation time. Okay, this is the our task. Now, this is the case for this is another case. This we are not going to study. This is for, I have just minimum how much features are required. Okay, for that we have to again to uh, go to the Weka software, and in the Weka software we have to see, we have to find the tree. Now see, this is the decision tree. We have to plot the decision tree, and here in the decision tree you have to count the number of these nodes. Root nodes are there. See, and see, this is standard error. Again, this is repeated. Then there is skewness, then kurtosis, maximum, minimum kurtosis. Like this, we have to count this. It will be 1, 2, 3, 4, 5, 6. This is over 6 weeks. Not taken. 7, 7 more. Okay, mode is also there. It's totally 8 features are taken for the decision tree, and out of 14 features, here only they have considered. Veka has considered only the 8 features. Okay, and for the each feature we have to find the accuracy, and we have to determine how much number of features are required. Okay, how to do that? That using Veka software, that we will see. You have to go to Vika, then there is pre-processing, and here it shows the number of features. And first of all, we have to untick all the features. We have to tick all the features, and the first feature that we are going to consider, that is standard error. Okay, standardization error, that we have to untick, and the last column, that is also for condition, that is also we have to untick. Remaining we have to remove. Okay, and we have to find the accuracy for standard error. Okay, next, here standard error and condition, these two columns we have to keep, and we have to go to the classify, and again consider the same decision tree that we have considered earlier. This is another, this is previous decision tree, this is second decision tree, and for that we can see that here there are 336 instances are there that are correctly classified, and for that accuracy is 7.2. Okay, this is for one feature. Okay, if you consider the two features, second feature is again we have taken skewness. How we have taken skewness? Why we have taken skewness? Because after standard error there is a skewness. Okay, hence you have to consider skewness, and for skewness and standard error and condition, we have to find the accuracy. Previously that was 67%. Now here we can see the 68.4%. Okay. Again, the third means for the here four features they have considered. Four mean courtesy skew standard error. For that it is getting 72%. Then again this is for 73. Like this for means for each feature you have to find out the accuracy. 67. If you consider one column or one feature, it is getting 67. Okay, 67. And slowly the accuracy is going to get increased. And here it shows that minimum five features minimum five features are sufficient. Okay, 73.2. Here you can see that it is increasing 67, 68, 72. It is somewhat reducing, but again it is increasing. Means here you can consider that minimum five features are sufficient for a computational analysis. Again, but in the decision tree, it has taken rather than five, it is taken three more features, that is maximum, standard deviation, and more. But the error, the accuracy has not got that much change in the accuracy. Okay, hence we can consider that the minimum five features are sufficient. But remember, the features should not be that much less in number, because it can have a problem of underfitting. To avoid that, we have to learn underfitting, overfitting, and correctly fitting. To avoid the underfitting problem, there should be the certain minimum depth to the decision tree. Hence, if you want to remove that depth, that means uh, underfitting problem, remove that underfitting problem, you can add these three. Okay, you can add these three. Okay. Now we will see. This is the introduction of the experiment. Now see, we will see how to perform this experiment. As I already told you, we have to first of all open the Veka software. Again, I will go to the Veka software. Open the software. Already 7 minutes are over. It is opening. It is taking time. Okay. Now again go to the Explorer. Yes, steps are shown. Veka. Then pre-processing. First step is to open file and upload the file that we have seen in the experiment number 6. Desktop, experiment number 6, all CSV file, utility, finance statistical. Now, here all the features are considered. We have to consider only classify, choose, freeze, J48, and start. Again, same process we have to repeat. Okay, this we have done in the experiment number 6. Experiment number 4 starts from here. Just Go to the trees. See here the see here the number of 15 features are considered. Okay, we don't have to consider 15 features now. Our first task is to consider the only one feature. And so this is a tree. Just right click here. We have to see the visualize the decision tree. Okay. Now see this. In this way you can see the decision tree. Just right click and fit to screen. Okay. In this way you can see the decision tree. Here the standardization error, root nodes, skewness, kurtosis, minimum, maximum, like this, these are seen. And as per the decision tree, we are going to see or find out the minimum number of features required. Okay, effect of number of features. Okay, I will first of all hide this. Okay, first of all, we will take the standard error because in the decision tree, it is the standard error is on the top. And first feature you have to take as a standardization error. Okay, first feature you have to take as a standardization error. Okay, and so go to the Weka software. Go to the Weka software here. Again, pre-processes. Here, select all and standardization error and condition. Remember, condition. There is compulsorily we have to choose the condition because we have to classify the feature. This should be there. Then again we have to go to the classify. Then choose the decision tree. Now start. Here you can see on the top what is happened. It show only one feature. Why is not showing? Again, I go to the feature. Okay. Think I forgot to remove this. Remove. Now standard error and condition is there. Now go to the classify. Then start. I will remove this. It is not required. Delete user. Okay. For this, only two features are there: standardization error and condition. For this, it is showing correctly classified as 336 and incorrectly as 154, and that 67.2 you have to use for this. Okay. Now next feature, that is go to the below standard skewness. Next will be the skewness. Again go to the Weka software. Again go to the Weka software processes. Again you have to open the file here because here directly it is not taking. Again you have to open the file. Again choose that file. Select all and then standardization error and skewness and condition. And remaining you have to remove. We are going to select these three and remaining we have to remove. To remove here. See, this is showing only three features are here and attributes three. It is showing here three attributes, but instead is a five. Again, go to classify. Here we have to choose only. Presently, we choose only decision tree. Next time you can choose other algorithms as well. And here start. Okay. Now see for the three attributes, its accuracy is increased from 67 to 68. That okay, I will for skewness it is increased from 67 to 68. Like this, same thing you have to do. For the other attributes as well, again choose final statistical data, again choose all, again go to the decision tree, standard error skewness and kurtosis. Now we have to choose kurtosis. We have to choose kurtosis, standard error, and skewness and condition, and remove other. Okay. Again go to the classify. Same, repeat the same process. Click on start. Here you can see for the four attributes means kurtosis, skewness, and standardization compulsorily will be there. Hence, the error accuracy is 72%. Okay, like this, you have to repeat this for median, minimum, maximum, and all for the eight attributes that are seen in the decision tree. Okay, and you have to note down the accuracy for that and draw a graph. Okay, and you can see though the five number of features are sufficient, but to avoid the underfitting, we are using 8 number of features. This you can make a conclusion. Out of 14, but out of 14, the features are reduced to 8. That is also a good task. We have reduced a lot of that will reduce a lot of computation tasks if you use only 8 features. Okay. In this way, we have found out our the target. What is our target? Select the relevant features. We have seen found out the relevant features. What are relevant features? These are the relevant features out of 14. Okay. In this way, we have completed this practical as well. Okay. This is experiment number 4. It's totally 6 practicals we have completed till today. And if you have any problem, you can pause on the video and do the analysis and do the submission. Thank you. Thank you very much. I will stop here.